All right, hello, it's Mr. Crozier. I'm going to go over page 2 of this worksheet to help you get started. Number 13, find the decreasing intervals. Well, that is the first derivative test. Anything with intervals is the first derivative test, which means you're going to have to make the chart. And we take the derivative, and we're going to look for endpoints, which are 0 and 2 pi. We're going to look for when is the derivative 0. Well, set this equal to 0. Add the sign over, divide by cosine. We have tangent of x is 1. There's my zeros. When is it undefined? Well, this is never undefined. Then plug in some points and you'll see what's going on. It's increasing, decreasing, increasing. On number 2, you have a function here, and it's asking the same thing for the increasing. Well, take the derivative, set it equal to 0. There's your point. Your point is a positive 1. The graph goes up and down at 1. And you can always take a look and see what's going on here. Negative 2x squared plus 4x plus 3, up, down, at 1. All right, going on. Here's the derivative, increasing, decreasing intervals. Well, that's a chart of critical points. And all we have to do is list them. So you're looking for points where the derivative is 0. Well, where's the derivative 0? Well, that would make the numerator must be 0 if I solve that. So we have these, and the denominator of 0 would make it undefined. So I have those. 1, 2, 3, 4 critical points. Those are the numbers that would fall on this chart. Those are the numbers we need. Mean value theorem. Take the slope, set it equal to mean value theorem says a value is equal to the slope. Rolle's theorem says it's equal to 0. Find it when it's increasing and decreasing. Well, usually we put negative pi over here. However, if you look at this graph, there's nothing defined over there. So those values are undefined. This parent function doesn't go past 0. This is all undefined area, so we're going to not include it. It's not part of the graph. So we're going to start from 0 to pi, or sorry, 0 to infinity. Take the derivative, set it equal to 0, solve, test your points, the graph goes down and up. This is a neat graph to look at. If you graph this, x third divided by 3 minus ln of x. Graph. It's only this little bit, and if I zoom in better, it goes down to 1 and then up, and that's what that's saying. It goes down to 1 and then up. Relative and global max, global min, relative min. Number 19, take the derivative. Well, what is the derivative of x absolute value? Well, that is x over absolute value of x, but don't forget to do the chain rule. So there's my derivative. Well, what are the critical points? Well, when the numerator is equal to 0, I get these. And when the denominator is equal to 0, I also get those right there. So those are your points. Plug them in, down, up, relative min, min, max. And here's your graph. Again, relative min, relative max, relative min. A global maximum. Well, you could graph it and look at it, but let's go ahead and do this first derivative test. And it's 1/2. So the graph goes up to 1/2 and down to 1/2. And that's everything on the graph. This whole graph is moving up, then moving down. So this point right here is a relative max, but it's also a global max. And again, just check it. You have time to check it on all your homework, so you're prepared for the test. Plus 3, let's delete all this stuff. Zoom 6, it goes up to 1/2 and down. Right there is where it's at. Why don't I zoom in on that for you? Click over here, press enter, hit trace, and watch what happens. This graph goes up. This graph goes up to about 0.5. Input, output, 3.5. Input, output, and it goes back down. And that's all it does. If I zoom out, That's all this graph does, because that's the only critical point. There are no other critical points. That's the only one. No matter how far out I zoom, that's the only critical point. Here's a function. Let all values be such that it's equal to the derivative. Well, just take the derivative set equals 0 and solve. Mean value theorem says, look, I need the slope. The slope is negative 1/5. Is equal to the derivative. Multiply this down, subtract 1. Chain rule is just 1. Put that in the denominator, put that in the denominator, and I divide it by a negative on both sides. Solve the equation, get to this point. Should be a 4 right there. Square both sides here, subtract 17/4. And on the last one, intervals are this, from 0 to 2 pi. Before I took the derivative, I just distributed it. It's in there. Derivative here is 0, derivative here is negative sign. Set that equal to 0, solve it, down, then up. And remember, when you're doing this first derivative test, you check endpoints. Number 2, f prime of x is equal to 0. Number 3, f prime of x is undefined. That's what you check. We have endpoints, we have zeros. Sine is a complete function, right? If I were to graph sine, right, this is a parent function. If I were to graph sine, there's no discontinuity in there. It is a straight line graph, no points of discontinuity. Don't have to worry about the bottom one. That's my point, down and up, plug in a point, decreasing, increasing. All right, I hope this helps. If you have any questions, I will see you in class.